You think you understand cosmic collapse. You have heard of neutron stars, ancient dead suns where gravity has crushed matter so relentlessly that atoms themselves cease to exist. A single sugar cube of this stuff would outweigh Mount Everest. Their cores are a swirling quantum soup of neutrons, the universe's densest known objects. They are the ultimate cosmic husks, the gravestones of stellar giants. But what if gravity still wasn't satisfied? What if there's a place beyond even that unimaginable density? A place where the fundamental forces of the universe, the very glue that holds reality together, unite into something entirely new, something alien, beyond comprehension. A place where chemistry itself dies, where the concept of an atom becomes a forgotten myth. The core of a dying star, after it collapses past the white dwarf stage, becomes a neutron star. Imagine taking every single mountain range on Earth, every ocean, every continent, every city, every living thing, and crushing it down until it fits into a sphere just the size of a city. That's the density we're talking about. A spoon of its material would outweigh Mount Everest. At this point, gravity has become an insatiable monster, so powerful it has overcome the electron degeneracy pressure that supports white dwarfs, forcing electrons to merge with protons, creating a star composed almost entirely of neutrons. These neutrons, packed together, resist further collapse due to something called neutron degeneracy pressure, a quantum mechanical repulsion that screams no more to gravity's relentless embrace. This is the universe's ultimate cosmic concrete, a barrier so dense, so incredibly rigid, that for decades, we believed it was the absolute final word in stellar evolution, short of a black hole. But the universe, my friends, is far more imaginative and terrifying than our neat little theories. Even in the heart of a neutron star, where gravity is waging its brutal war, there's a last, desperate line of defense, the strong nuclear force. This is the most powerful force known to physics, the very glue that binds quarks together to form protons and neutrons. It's the titanic grip that keeps those subatomic particles from flying apart, even under pressures that would obliterate anything else. Think of it as the ultimate cosmic bouncer, preventing the fundamental constituents of matter from being torn asunder. For all the neutron star's crushing power, the strong force still holds its territory, preserving the individual identity of those neutrons, maintaining the fragile integrity of their quark components. It's a furious microscopic standoff, a silent battle waged trillions of times per second, deep within that ultra-dense core. But what happens when gravity, that relentless, devouring void, pushes even harder? When the mass of that neutron star grows so immense, so utterly gargantuan, that even the strong nuclear force, the most powerful cosmic binding agent, begins to buckle. This is where our understanding shatters, where physics as we know it screams in protest. We're talking about pressures that make the heart of a neutron star look like a gentle breeze. Imagine a pressure cooker, not just holding steam, but holding the entire universe inside, then compressing it down to the size of a single grain of sand. This is the theoretical threshold, the breaking point where the strong force, for all its immense power, is finally overwhelmed. It's like trying to hold back a tsunami with a single hand. The quarks, those fundamental building blocks, can no longer maintain their distinct identities within the neutrons. They are squeezed, distorted, and ultimately liberated from their confinement, forming a chaotic, degenerate soup. This isn't just a slight increase in density. This is a cosmic phase transition, a fundamental shift in the very nature of reality. It's not just a denser form of matter, it's a completely alien state, where the rules of the subatomic world are fundamentally rewritten. Think of it like water turning into ice, but instead of ice, it transforms into a material that defies all known properties, a substance so bizarre it barely exists within the realm of our mathematics. The strong force, the force that defines the very existence of protons and neutrons, is no longer the dominant player. Its iron grip finally yields. At this unimaginable pressure, the universe crosses an invisible barrier, a cosmic event horizon, not just for light, but for the fundamental forces themselves. What emerges beyond this threshold is not just a denser star, but a theoretical monster, a true anomaly, where the very concept of distinct subatomic particles, as we understand them, begins to unravel. This is the first terrifying glimpse into the heart of an electroweak star, a place where matter itself is stripped bare, exposed to forces so extreme they echo the first nanoseconds of the Big Bang itself. It's a star that lives at the edge of the impossible, a cosmic enigma that forces us to question everything we thought we knew about the universe's ultimate limits. Remember that terrifying boundary we just crossed? The one where the strong nuclear force, the very cement of protons and neutrons, finally buckled under gravity's monstrous grip? That was just the beginning, because at these unfathomable energies, at these pressures that echo the first picoseconds after the Big Bang, something even more profound, more mind-bending occurs. Two of the universe's fundamental forces, forces that have always seemed distinct, separate, almost like cosmic siblings with entirely different personalities, suddenly merge. They become one. Think of the electromagnetic force. This is the force you know, the one that governs light, electricity, magnetism. It's the invisible hand that pulls opposite charges together and pushes like charges apart. Crucially, it's the force that binds electrons to atomic nuclei, creating the atoms that form everything you see, everything you touch, everything you are. It's the architect of chemistry, the reason why carbon can bond with hydrogen, why water exists, why life can even contemplate its own existence. It defines the very structure of matter, giving it shape and form. And then there's the weak nuclear force. This one is a bit more elusive, a bit more of a cosmic trickster. It's responsible for radioactive decay, for the way a neutron can transform into a proton, spitting out an electron and an antineutrino. It's the force that changes the identity of particles, allowing one type of quark to transmute into another. It's subtle, it's fleeting, but it's absolutely essential for processes like the nuclear fusion that powers our sun, allowing light and warmth to flood our solar system. Normally, these two forces dance to different cosmic tunes. They operate at different strengths, govern different interactions, and behave as distinct entities. But at the crushing, mind-destroying energies within the core of a forming electroweak star, a quantum wedding takes place. Imagine two powerful separate rivers flowing through their own distinct canyons, each shaping the landscape in its unique way. But then they converge. They meet in a cataclysmic confluence, their waters churning, their identities blending, until they form one single, turbulent, unstoppable torrent. This is the electroweak force. In this unified state, the distinction between the electromagnetic and weak forces simply vanishes. It's not that one dominates the other, it's that they become two facets of the same fundamental cosmic entity, and the implications for matter are nothing short of apocalyptic. When the electroweak force reigns supreme, the very concept of separate quarks and leptons, the fundamental particles that make up all matter, becomes meaningless. Electrons, those tiny elegant dancers around the nucleus, lose their distinct identity. Quarks, once the proud components of protons and neutrons, cease to be individual entities. There are no more protons, no more neutrons, no more electrons. And if there are no more of these building blocks, then there can be no more atoms. The very notion of a nucleus, of electron shells, of the intricate, beautiful dance that creates elements and molecules, it all collapses. Chemistry, the science of how atoms bond and interact, the foundation of all complexity, simply stops. It's erased from existence. An electroweak star is a realm where the universe has forgotten how to build. It's a sphere of pure, undifferentiated energy and matter, where the laws of physics that govern our everyday reality, the laws that allow a star to burn, a planet to form, a human to think, have been fundamentally rewritten. It is a cosmic void where the very concept of structure, of a distinct thing, has been annihilated. It's a terrifying echo of the earliest universe, frozen in time, a monstrous relic of an era where reality itself was still deciding what it wanted to be. If you're ready to dive deeper into these cosmic nightmares and uncover the universe's most shocking secrets, make sure to like this video and subscribe to the channel. We're just getting started on this journey to the edge of reality, and you won't want to miss what comes next. We just witnessed the ultimate cosmic divorce, where gravity shattered the strong force, and then the ultimate cosmic wedding, where electromagnetism and the weak force fused into one. What is left? A theoretical abomination, an object so alien it barely qualifies as matter as we know it, the Electroweak Star. Imagine, for the briefest, most incandescent fraction of a second after the Big Bang, the entire universe existed in this very state. All four fundamental forces, gravity, electromagnetism, the strong force, and the weak force, were unified into a single primordial superforce. As the universe expanded and cooled, this superforce broke into the distinct forces we recognize today. But an Electroweak star, it's a cosmic fossil, a living, breathing, or rather non-breathing echo of that primordial soup. It's a piece of the early universe, frozen in time, a monstrous relic that somehow endured the cooling and differentiation that shaped our reality. It's a time capsule of ultimate physics, a terrifying glimpse into a moment when existence itself was still forming its rules. In its heart, there is no chemistry. Let that sink in. No atoms, no molecules, no protons, no neutrons, no electrons as distinct entities. The intense pressure, the overwhelming electroweak force, has obliterated all distinction. Picture a perfectly smooth, featureless sphere, not black, like a black hole that devours light, but perhaps a shimmering, formless void, a kind of antimatter, anti-structure. It wouldn't glow because light is born from atomic transitions, from electrons jumping between energy levels, from the dance of charged particles. But here, there are no distinct charged particles, no energy levels to jump between. It's a universe where the very concept of light, as we understand it, might be meaningless in its interior. It's a silent witness to physics unraveling. Every law, every constant we've painstakingly derived that governs the formation of stars, the existence of planets, the intricate machinery of life, it all screams to a halt at its theoretical boundary. This object isn't just dense, it's featureless. It's a uniform, degenerate fluid where quarks and leptons have dissolved into a single, unified plasma. Think of it like a cosmic melting pot, but instead of melting metal, it melts the very identity of fundamental particles. All complexity, all structure, all potential for anything beyond raw, undifferentiated existence is utterly crushed out of it. And here's the truly terrifying part, its stability. Once formed, these cosmic anomalies aren't fleeting. Unlike some exotic particles that wink in and out of existence, an Electroweak star, if it forms, would be incredibly, terrifyingly stable. It's a perfect balance of unimaginable gravitational pressure and the outward push of this unified Electroweak degeneracy pressure. It's a permanent scar on the fabric of space-time, a monument to physics, broken and remade. It would persist, unchanged, for longer than the age of the universe itself, a silent, featureless testament to a reality where our most fundamental assumptions about matter and energy simply do not apply. It's a star that isn't a star, a form of matter that isn't matter, a cosmic entity that forces us to question the very definition of existence. It's a sphere where physics has gone mad, where the universe has forgotten how to be complex, how to build anything more intricate than a featureless, undifferentiated blob. It's a haunting echo of creation's first moments, frozen forever in a state of impossible equilibrium, a true cosmic paradox that whispers secrets from the dawn of time. Imagine trying to observe something that defies the very laws that create light, that dictates the behavior of atoms. How would we even know it's there? Its gravitational pull, yes, but beyond that, a perfect, silent, featureless abyss, a cosmic horror, beautiful in its pure, terrifying simplicity, enduring perhaps until the very last light of the universe fades. It's a star without a shine, a ghost in the cosmic machine, a silent, eternal monument to the death of chemistry. So we have this theoretical monster, the Electroweak Star, a relic from the dawn of time, a place where chemistry is dead, where fundamental forces are fused. But why do we even care about such an outlandish concept? Because these hypothetical objects are more than just theoretical curiosities. They are, in essence, cosmic Rosetta Stones. They are unique time capsules, perfectly preserved fragments of the universe's earliest moments. Imagine trying to understand the first nanoseconds of the Big Bang. Are particle accelerators, as powerful as they are, can only glimpse conditions that existed a tiny fraction of a second after creation. We can smash particles together, trying to recreate those primordial energies. But an electroweak star, it's a naturally occurring, stable remnant of those exact conditions. It's like finding a perfectly preserved fossil of the first single-celled organism, giving us direct insight into the very origins of life. These stars, if they exist, would be living laboratories, offering a direct window into a time when the universe was so hot, so dense, that the fundamental forces themselves were indistinguishable. They would hold the secrets of cosmic inflation, the nature of dark matter, perhaps even the origins of consciousness itself, locked within their featureless cores. The ultimate search for these objects becomes a thrilling, desperate hunt for answers at the very edge of reality. We can't see them. They don't emit light in any conventional sense because there are no atoms to produce it. They don't have event horizons like black holes that warp space-time in predictable, observable ways. Their very nature defies our most common detection methods. It's like trying to find an invisible, silent, perfectly camouflaged predator in a cosmic jungle. But we are strategists. We are cosmic detectives. How do you find something that fundamentally resists detection? You look for the subtle whispers, the indirect clues, the gravitational ripples they might leave in their wake. We would be searching for gravitational wave signatures that don't quite fit black hole mergers, or unusual gravitational lensing effects that defy explanation by known objects. Perhaps they subtly affect the orbits of nearby stars in ways that a neutron star or black hole wouldn't. It's a game of cosmic chess where the pieces are invisible and the board is the entire universe. The pursuit of the Electroweak Star is not just about finding a new type of stellar object. It's about pushing the boundaries of human knowledge itself. It's about confronting the possibility that our current understanding of physics is incomplete, that there are entire realms of existence, entire states of matter and energy that we have yet to even conceive of. Every anomaly, every faint signal that doesn't fit our existing models becomes a tantalizing clue in this grand cosmic mystery. Are those strange gravitational wave bursts from unknown sources? Could they be the faint echoes of an electroweak core shifting? Is there an unexplained wobble in a distant star's orbit that hints at an invisible chemistry-killing companion? This quest is a testament to the audacity of the human mind. To even imagine such an object, to derive its theoretical properties from equations that scream at the edges of our comprehension, is a triumph. To then embark on the almost impossible mission of finding it, of proving its existence, is the ultimate gambit. It's the thrill of the chase, the intellectual struggle against the unknown, the desperate yearning to pull back another veil from the cosmic tapestry. The universe is playing its cards close, but we, the cosmic strategists, are determined to uncover its ultimate secrets, even if those secrets shatter everything we thought we knew. The hunt is on, and the stakes couldn't be higher. We are searching for an object that would force us to rewrite the textbooks, to rethink the very fabric of existence, and to stare into the face of a universe far stranger and more profound than we ever dared to dream. We've journeyed into the heart of a cosmic nightmare, a hypothetical realm where the very concept of matter, of chemistry, of distinct particles utterly dissolves. The Electroweak Star isn't just a denser object. It's a living fossil from the universe's infancy, a stable, silent monument to the death of atoms and the fusion of fundamental forces. It's a place where the rules we live by, the laws that allow stars to burn and life to flourish, simply cease to apply. The very idea of such an object pushes our understanding of physics to its breaking point, forcing us to confront the limitations of our current models. It reveals a universe far more extreme, far more imaginative, and infinitely more bewildering than we could have ever conceived. These theoretical monsters are not just curiosities, they are profound philosophical challenges, whispering secrets from the Big Bang itself, hinting at a reality where the known elements are merely a fleeting phase. Tell me what you liked or disliked about this video. What do you think could be changed to make it better? I read every comment and will respond to every suggestion.